guys, Eddie the Magic Monk doing another lesson on binomial distribution. This is part 2 of the binomial distribution, so hopefully you guys have done the first lesson and you've done a simple example where we run an experiment where there are two possible outcomes. So I used shooting and basketball as an example. So we took 3 shots. What is the probability of getting a certain number of shots in the ring? And you can see I made up a little binomial distribution table, and we said that if you took 3 shots, the probability of getting 0 shots in is 0.008. Probability of getting 1 shot in is 0.096, and so on. So this was all pretty easy. However, the way that we did it, so for example, when we did the probability of getting 1 shot in, we got 3 possibilities. If you get the first shot in, so P means getting a shot in, Q represents missing a shot, so PQQ means missing the first shot, getting the next 2 shots in. Probability of that happening plus the probability of missing the first shot, getting the second shot, missing the third shot, and so on. And you can see these combinations, PQQ, QPQ, QQP, we had to list them out manually. Okay, but what if we were in a situation where we took, for example, 8 shots? Now, it's going to be a little bit harder to fill out this table, because let's say I want to know the probability of getting 3 shots in. So probability of getting 3 shots in. So that's going to be, the probability of success is P, so that could be P, 3 shots in initially, and then you miss 5 shots. Or you could go get the first shot in, miss the second shot, get the third shot and the fourth shot, and miss the next 4 shots. There's a lot of possibilities, and it's almost impossible to write it all out manually because there are just so many possibilities. So how do we know how many possibilities are there? Now we're going to use a function on your calculator to do this, and the function is called combinations, which is a key that looks like this, NCR. Now I have another tutorial on combinations alone if you want to watch that, but basically what combinations are is a way for you to find out how many ways are there of selecting R objects from N objects. So if you imagine we're shooting the basketball, each shot, the outcome of each shot is represented by a box. Now we're taking 8 shots, that's why there are 8 boxes. Now how many of these which one of these boxes are we going to pick to be our shots in the ring? Now we need to pick 3 of them. So 3 of these boxes, which ones are we going to pick? Are we going to pick the first 3? Or are we going to pick the first 2 and then the 4th one? Or are we going to pick the first one, the last one, and the second and last one? How many ways are there of picking 3 objects out of N objects? So to do that on your calculator, all you need to do is type N equals 8, R equals 3. So all you have to do is type 8C3 on your calculator. So on the calculator, let's go into math, probability, NCR, and oops, we probably should type 8, math, probability, NCR 8C3, and you get 56. So there are 56 ways. There are 56 ways we can write out 3 P's and 5 Q's. So we're not going to keep going like that because we already know that there are 56 ways. So probability of 3 shots in is going to be 56 times. Now each of these has P to the power of 3 and Q to the power of 5. So it's just 56 times P to the power of 3, Q to the power of 5. So the answer is 56 times. Now if you guys remember, I said that P was equal to 0.8, your probability of success, and the probability of failure was 0.2 to the power of 5. So if you put that in your calculator, you will get 0.009175. So we can put that in our table, 0.009175. So where do we put that? Well, we got 3 shots in, so that would be over here. So let's use another color. 0.009175. So that's just for this box. So we can fill in all of these boxes. I might just get you guys to try this box here. What is the probability of getting 5 shots in? So try that and come back when you're done. So the problem is 8C5, all right, because we're trying to get 5 shots in. And how many shots do we have going in? So that's probability of success to the power of 5 times we got 3 shots fail, so Q to the power of 3. So that's the probability of getting 5 shots in. So if you type that into the calculator, you will get 0.1468. So that would go here. 0.1468 and so on. Feel free to fill out any of these other boxes. Hopefully you guys have worked out a little formula. So the formula for the binomial distribution is this. NCR P to the power of R Q to the power of N minus R, where N is the number of trials, R is the probability of, R is the number of successes, P is the probability of success, and Q is the probability of failure. Okay, so I guess you guys can understand what's happening now. I will give you one final question, a totally unrelated question, and see if you can do it. So just a quick question. The chance of a flower surviving after being planted is 0.2. So probability of success is 0.2. Because we later asked find the probability that 2 flowers will survive. So P is the probability of success. Q is the probability of failure, which is going to be 0.8, because remember P and Q, they must add up to 1. So we plant 4 flowers, so N is equal to 4, because that's how many trials we're running in the experiment. Find the probability that 2 flowers will survive, so R equals 2 successes. So NCR P to the power of R Q to the power of N minus R equals 4C2 times 0.2 to the power of 2 times 0.8 to the power of N minus R. So 4 minus 2 is 2. So what's the answer there? 0.1536. Okay, thanks for watching, guys. Hopefully you've learned something today. See you next time.